Hello, in this tutorial we are going to learn how to convert the star connection into delta connection and vice versa. I use a completely different approach to tackle this problem. The solution for this problem needs no any complex formula and you can also remember it for long. So let's first visualize what the delta and star connection look like. First let's go to delta connection. So this is our connection, 3 resistors are connected in this nature. So what we do is let's cut it from a node. Let's cut it from this side and it will change into this network. As you see, these 3 resistors are connected in series when we cut it over here. So you can remember delta as series connection network. So for star network we can change this network connection like this and like this. So what you see from here is star connection can be taken as a parallel connection. So after visualizing the delta and star connection, we now can formulate the following results. To convert into star connection, we can use the parallel connection of resistor formula, and to convert into delta, we can use the series connection of resistors. The main idea of solving this problem is using the pairing rule. What we do is, instead of the equivalent resistance, we replace equivalent resistance with the product of the resistor in delta connection times the resistor in star connection, whereas we replace these resistors R1, R2 and R3 as the product of two adjacent resistors from them. So without looking the formula, we directly go to the problem solving and find out how to solve the problem. So the first problem is from delta to star conversion. Suppose this is the question, we need to convert this delta connection into the corresponding star network. So the first thing you need to know is, since this is conversion from delta to star, so we are going to use the resistance in parallel combinations. So let's find out first the value of X of this resistor. We can use this formula to write like this. Re can be replaced by the product of delta and star. The one resistor is in X like this, and the corresponding delta resistor is 20 ohm. As you see from here, this resistor is pointing towards this resistor, so X and 20 will pair and form equivalent resistance. And for R1, just consider 80 ohm as R1, then the adjacent resistors connected to it will be 30 ohm and 20 ohm. So we write the product of 30 and 20 here. Similarly, taking 30 ohm as a resistor, the adjacent resistors will be 20 ohm and 80 ohm, so we put 20 and 80 over here. Similarly, taking 20 ohm as our resistor, the 80 ohm and 30 ohm will pair to form this. So by solving this equation, we can get X equals 18.46. In a similar way, to find X, we can use the same relation. First of all, the equivalent resistance is the product of X and its corresponding delta resistance, that is 30 ohm, so X times 30 equals to the adjacent resistance is 30 20, 20 80 and 80 30. Similarly, we can get this value, and similarly for this also we can get the resistance in similar way. So let's reverse this problem. We change from star to delta conversion. So this is the result that we just got from the initial problem. So this star network is to be converted into delta connection, so we need to use the series connection. So by using this formula, let's find the value for X. We can replace Re with the product of resistor, that is X is in delta and its corresponding resistor in star connection, that is just opposite of this, that is 4.61, and which is equal to the product of two adjacent resistor, that is 4.61 and 12.31, 4.61 and 18.46, and 12.31 and 18.46. By solving this, we can get X equals 80 ohm, and you can just similarly apply the rule. X and 18.46 will pair in this way, then they will pair in the same way as before, and we can get X equals 20. Similarly, we can get X equals 30. So what result you obtain from here is, you did not remember the strict formula for star delta interconversion. You can use the same formula that we use in parallel or series combination to do this star delta interconversion. The only thing you need to remember is you need to replace the resistors with the product of two resistors, and this product of two resistors can be easily obtained from the geometry herein. So what you learned today is every connection is either parallel or series. It only depends on how you see it. So thanks for watching.